On to part C, which gives us 5x times the cube root of 81x plus 6x times the cube root of 24x. Again, if we want to have any hope of adding these, we need to simplify each individual radical and see if we end up with like radicals. So we have to simplify the cube root of 81x, and we also have to simplify the cube root of 24x. All right, so let me run through that quickly. For the cube root of 81x, we break the 81 down into 3 times 3 times 3 times 3, and because we're dealing with a cube root, we're looking for a group of 3 identical factors. 1, 2, 3. So this group of 3 3's comes outside the radical as a single 3, and this guy stays in. With the x's, there's only one x factor, so you can't break one x into a group of 3, which means that no x's come out and that one x stays in. So altogether, the cube root of 81x becomes 3 cube roots of 3x. Now for the cube root of 24x, we break the 24 down into 3 times 2 times 2 times 2, which means a single 2 comes outside of the radical, and a 3 is going to stay in. Also, this x cannot be taken out of the radical because there's not 3 identical factors. There's not enough factors, just like before. So the x stays in, and the 3 stays in, and the 2 comes out. So we end up with 2 cube roots of 3x. So back in the original problem, I'm going to replace the cube root of 81x and the cube root of 24x and see if I can collect my like radicals. So the expression becomes 5x times, instead of the cube root of 81x, I'm going to write 3 cube roots of 3x. Plus 6x times, instead of the cube root of 24x, I'm going to write 2 cube roots of 3x. Let me go ahead and do the multiplication here, right? 5x times 3 is 15x. Then I have a cube root of 3x. Plus 6x times 2 is 12x. And I still have a cube root of 3x left here. So now we can collect our like radicals, right? We have a cube root of 3x in each term. So in order to collect these cube roots, we have to add the coefficients. 27x is my result after I add 15x and 12x. So altogether, my expression becomes 27x cube root of 3x. Right, so I added the coefficients, and then I take the like radical and stick it on the end. So this is my simplified expression for part C. So for part D, we need to simplify 9 root 44 minus 10 root 13. Shouldn't be too bad, hopefully. We're going to start by breaking down each radical individually. So I'm going to simplify root 44. Right? Root 13 is already done. Right? 13 is a prime number. You're not going to find any pairs of factors in there. So this guy doesn't simplify. But root 44 we can break down. So let's do that. So root 44, when you break it down, has a 2, a 2, and an 11. So the pair of 2's comes out as a single 2, and the 11 stays in. This is sort of suspicious. Right? Let's see what we get when we plug in 2 root 11 for root 44. We're going to end up with 9 times, instead of root 44, I'm going to write 2 root 11 minus 10, and we still have this root 13 that we could not simplify. So altogether we have 18 root 11 minus 10 root 13. You'll notice the root 11 and the root 13 are not like radicals. And they don't simplify anymore because they're both prime numbers. So that's it. That's all we can do. We can't make this look any prettier because we don't have any like radicals to combine. So there's your final answer for this one.